Hey everyone, thanks for joining for another Apache Pinot meetup. Today we have a great topic, segment assignment and theta sketches in Apache Pinot. We have two presenters today. We have Jackie and Mayank. I'm going to actually bring them in to say hello. Hey Jackie and Mayank.
Hello everyone. Hi Corinne. Hi Corinne.
So really quick before we get started, so we're going to start off with Jackie's presentation, then we'll do a Q&A, then we'll go over to Mayank, and then we'll do another following Q&A. If you have any questions for the viewers while you're watching, feel free to ask in the chat. Mayank and Jackie will both be here, plus some other people from the StarTree team, so they'll be able to also answer questions in the chat, but we will also be doing a Q&A at the end. Generally, there's like a 10 to 15 second delay. So if you see us kind of wrapping up, that's the best time to ask the question. You can ask it a little bit ahead of time and then we can do the Q&A with everyone. Also, if you like this video and the content is great, please give it a thumbs up and don't forget to subscribe. And yeah, I think that pretty much covers it. So I'm going to do a little intro for Jackie because I like introducing people. So Mayank, I'm going to put you backstage and then we'll bring you back out after Jackie's presentation.
All right, see you in a bit.
All right. So if you haven't already met Jackie, I'm very sorry. He does all these meetups pretty much every week now, and he's very, very active in the Slack group as well, Slack channel. Also Mayank, very, very active, and he's in every meetup also, at least answering all the questions. So these are like really great speakers. I'm really excited about it. So just to give a little background on Jackie is a founding engineer at StarTree. And before that, he worked at LinkedIn Pinot team for more than 4 years and became the PPMC and one of the top contributors for Apache Pinot. His goal is to make Apache Pinot the fastest online analytics platform in the market. He got his bachelor's degree from Tsinghua University and his master's degree from Carnegie Mellon. And yeah, that's Jackie's story. I think the bio is a little bit twisted. So, okay, Jackie, I'll let you take it away. And thank you guys all for joining, and we'll see you right after Jackie's presentation for Q&A.
Hi, everyone. Thanks for attending. So yeah, today I'm going to talk about the segment assignment in Apache Pinot. So yeah, let's start with some basic concept. So what is segment? So segment in Pinot is the smallest query execution unit that contains the indexes for a batch of records. Pinot table is physically stored as segments on Pinot server. So all the data is stored as segments, and also the query target is also the segments. Then what is segment assignment? So segment assignment is the process of assigning the segments to Pinot servers to host the data. For example, we have this table, and then this table is consisted of these 4 segments. So basically, the goal of segment assignment is assigning these 4 segments to the servers to host them, basically to host the table. So if we further split, segment assignment can be split into 2 steps. The first step is called instance assignment. What it does is for each table, the instance assignment pick the servers to host the data for the table, or to host all the segments for this table on this set of servers. Then after the servers are picked, the segment assignment assign each segment to the picked servers. Okay, so now we have covered all the most basic concept. Let's start with an empty cluster, and I will use some examples to show different segment assignment strategies. So let's start with an empty cluster. For the segment assignment, for this topic, controller and broker are basically out of our scope. So here I will just cover the server and how the segments are assigned. So from an empty cluster, let's add the first server. Okay, now I have 1 server. I can add my first table. So because there is only 1 server, for the instance assignment, I will pick this server 1 to host the segments for table 1. Okay, now I have a server for this table. Let's push the first segment for table 1. Because there's only one server assigned to this table, the segment 1 is assigned to server 1. Okay, now I have more data for this table 1. I want to push more segments for table 1. Assume like I don't have enough capacity on server 1. So in this case, I might want to add a second server to host the extra segments. So the assignment becomes like this. Okay, now everything looks good, but what if a server goes down? Let's see if server 1 goes down. Then segment 1 and segment 2 becomes unavailable. And then basically, this table is no longer complete. So how can we handle it? The solution would be we will add a replica to all the segments. So basically what that means is we add another two servers and then basically make 2 replicas for each segment. So even if server 1 goes down, we can still find segment 1 and segment 2 on the other new ID servers. So the table is still available. Okay, so far we have covered the most basic segment assignment. So this is the default segment assignment called balanced segment assignment. This assignment strategy assign all the segments balanced to all the servers. And each server will host the same number of segments, minus or plus 1. And then the replicas of the same segment won't be assigned to the same server. The reason for that is clearly if we assign multiple replicas to the same server, if that server goes down, then both replicas will down, and then the table becomes incomplete. So for balanced segment assignment, because there are no special rule for the segment assignment, just assign balancedly, each query can be routed and hit all the servers. And then server load is balanced among all the servers because each server hosts the same number of segments. So the default segment assignment is ideal for small tables hosted by a small number of servers. Okay, now let's expand this table. I want to add even more segments, maybe way more segments and servers for this table. So let's see. So for example, right now I have 4 servers hosting 4 tables, and then each segment has 2 replicas. As I just mentioned before, so the query can hit all the servers. And then the problem of this is querying too many servers can harm the query performance due to the overhead of the increased fanout. So for a large table, let's assume there are 100 servers. So for each query, you will route this query to 100 servers and then gather result from them. So this overhead of finding out the query to 100 servers is not negligible. So how can we solve this problem? So our target is to reduce the fanout. So what we can do is we can group the segments in a certain way to reduce the servers queried for each query. For example, what we can do is, since we have 2 replicas of each segment, we group the segments for the same replica into one subset of all the servers. And then in this case, because server 1 and server 2 already contains all the segments for one replica, the query only need to hit these 2 servers. It doesn't need to be routed to server 3 and server 4. So this is called the replica group segment assignment. What it does is it assigns one replica of all the segments to a set of servers. So this set of servers is also called replica group. Then we mirror the assignment for other replicas to other sets of servers. In this case, because like each replica group hosts all the segments, each query only need to hit the servers within a single replica group. So another big benefit of this replica group segment assignment is it is horizontal scalable. For example, like right now, my table is good for 1000 QPS throughput. So I want to increase the throughput to 2000 QPS. Then I can easily like increase the throughput capacity by like doubling the number of replica groups. And all the queries will still hit the same number of servers. So this segment assignment is ideal for large tables with high throughput. If we can, let's see if we can do better. If we want to further reduce the fanout, then what we can do is we can partition the table and then group the segments of the same partition to reduce the segments or to reduce the server's query when the query does not hit all the partitions. For example, here, if we already partition the table and then we put all the segments for partition 1 on server 1, partition 2 on server 2, and if the query only hits partition 1, I only need to route the query to one server. So this further reduces the fanout of this query. This strategy is called partition replica group segment assignment. So it's similar to replica group segment assignment, but it's aware of the partition of the segment. So it can assign the replica of all the segments from the same partition to a set of servers. And then it will repeat this process until segments from all the partitions are assigned. Then we mirror the assignment for other replicas to other set of servers. This strategy is ideal for large tables with very high throughput. For example, tens, thousands QPS throughput. Okay, now we have covered the strategies for a single table use case. Let's add another second table into our cluster. Assume right now the servers are assigned, like both servers are assigned to table 1, and then there's one segment on server 1, one segment on server 2, and then I want to add a second table. In this case, both servers are picked to host the second table. And then basically both the segments from table 2 will be assigned to both server 1 and server 2. So basically here, because both server 1 and both segment table 1 and table 2 are assigned to these two servers, the queries for both table 1 and table 2 will hit both servers. Basically, these two tables share the same compute resources. So the problem of this approach is the slow query for one table can impact the performance of the other table. Let's say one very large scan query, for example, it exhausts the compute resource on these two servers. Then basically the query from the second table need to wait until the resources are available. So what can we do to solve this problem? So there's a strategy called tag-based instance assignment, or another name is called tenant isolation. So basically what we do is we add tag to each server, as shown here. So server 1 and server 3 are tagged as tag 1. Server 2 and server 4 are tagged with name tag 2. And then when we assign instance for the table, we only pick servers from a certain tag to host the segments. So for example, here we pick tag 1 for table 1. So the segments from table 1 will only be assigned to servers under tag 1. And then similarly, the segments for table 2 will only be assigned to servers under tag 2. So as we can see, so with tag-based instance assignment or tenant isolation, servers are not shared for different tables. And then query load on one table won't impact the performance of other tables because basically, yeah, one query, the query from one table won't hit the servers for another table. So this assignment strategy is ideal for performance-sensitive tables. So, for example, like some like characteristics of the performance-sensitive table, it's like, for example, it has very high throughput SLA and then very strict latency requirement, like under 10 millisecond P99. And a typical use case for this kind of table is user-facing use cases. Okay, so let's see if I want to add more tables. And if these tables are not performance sensitive, it has low throughput, it does not have strict latency requirement. Typical use cases are dashboard use cases. So users can wait, for example, like 1 second for a query to respond. And also, typically the throughput for dashboard use cases are low, like usually single-digit QPS. And then the tables are usually of various size, can vary from megabytes all the way to terabytes. So for this kind of use cases, we want to reduce the cost to serve, and we want to reutilize the compute power of servers more efficiently. How can we do this? So yeah, I don't have a name for this instance assignment strategy, but basically what it does is it can control the number of servers picked for each table. So we maintain a server pool that are shared among all the tables. And then each table is hosted by different number of servers based on the table size. The reason being, so the queries for large table, we want the query to be executed by more servers in order to fully utilize the server compute power on all these servers and reduce the latency. But for small tables, I don't want the query to be routed to all the servers because of the overhead of fanout. And then the execution cost itself is low. So here's an example. As we can see, I have 6 servers, and then I only pick server 1 for the small table 1, and then I pick all 6 servers for the large table 2. Okay, so far so good, but there are also some problem of large number of shared servers. Let's see, I have hundreds of tables hosted on this shared servers. And then if I pick any 2 servers, because there are like hundreds tables hosted on them, so there is very high chance that 2 replicas of the same segment from a table are hosted on these 2 servers. Like any 2 random servers, there's very high chance, like 2 replicas of the same segment are hosted. So if these 2 servers are shut down at the same time, basically both replicas of this segment are down, which breaks the no downtime guarantee. Basically, the no downtime guarantee means when I shut down the server, the table should still be complete and available. So in order to maintain no downtime and restart all the servers for this server pool, for example, we want to deploy the new Pinot version. It could take a very long time because each time we can only bring down 1 server. So assume like restarting 1 server take 10 minutes. And then if I have 150 servers, it will take more than 1 day to restart all the servers. Then we designed this strategy called pool-based instance assignment strategy to solve this problem. Basically, what we want to achieve is we want to shut down multiple servers without breaking the no downtime guarantee. So that also means that these servers cannot host multiple replicas of the same segment for any table. So how do we achieve that? So we group the servers into multiple server pools, and then the replicas for the segment is always hosted by servers from different pools. So for any segment, if it has 2 replicas, the servers will be coming from 2 different pools. If it has 3 replicas, then 3 pools. So with this assignment strategy, all the servers within the same pool can be shut down at the same time, because there's no 2 replicas on the servers of the same pool. Let's say I have 2 pools, then I can fully restart all the servers in 2 steps. First step, shut down the pool 1, and then second step, shut down pool 2 without bringing down any table. Let's take an example. So here I put server 1, 2, 3 into pool 1 and server 4, 5, 6 into pool 2. So all this segment, it has 2 replicas. 1 replica goes to pool 1 and replica goes to pool 2. Let's say I shut down the whole pool 1. So there is still 1 replica up for all these segments in pool 2, and then the table is still in good state. Okay, so far I have covered all the assignment strategies. So it's break into 2 categories. One is segment assignment. I've covered the balanced segment assignment, replica group segment assignment, and partition replica group segment assignment. For the instance assignment, I've covered the tag-based, the control number of servers, and also the pool-based. So with all these assignment strategies, we can serve use cases from performance critical ones like thousands QPS, single digit latency, all the way to the dashboard use cases where latency requirements not that high and then throughput is usually low. But we can utilize all the compute resources or Pinot servers more efficiently. Okay, here are some further reading list. So in this talk, I haven't covered how to actually configure the table config to utilize all this segment assignment. So please go to the Pinot doc for the detailed config. And then also to change assignment strategy is fairly simple. So user just need to update the table config and then run a rebalance. Then Pinot will handle the rest of the work. And then and also the rebalancer can rebalance any table without any downtime. Thanks. That's my talk. And any questions?
Thanks, Jackie. So since there is a slight delay in the questions, like with the recording, there's a slight delay for like the live stream on YouTube. So it takes a minute for the questions to come in, I think. So we can give it a minute and see if there's anybody who has any questions. I also want to add, thank you. I also want to add that if you don't have the opportunity to ask the question now, or you're watching the recording afterwards, you're welcome to jump into the Pinot Slack also and ask Jackie questions there, or give him comments about the talk or what he's built and what he's worked on and things like that. That's a really big deal, I think, to give feedback. So we can give it another second and see if anybody has any questions. And if not, then we can kind of bring in Mayank. Okay. Cool. Jackie, thank you so much for doing this every week. All right, cool.
Okay. I'm enjoying
it. Someone here, we do have a question. Rahid asked, great talk, Jackie. Can you update, change segment strategy in an already running cluster?
Yes. So that's what I mentioned here about the rebalancer. So in the already running cluster, to update or change the assignment strategy is fairly simple. So what you need to do is just update the table config and then run the rebalancer. And the rebalancer will take care of everything without downtime. So if you, for example, without downtime, in a sense, if you have, for example, 3 replicas, the rebalancer can keep 2 replicas up while moving the segment around. So it's quite handy.
We have another question from Logic Matt. How can I create a segment pool for a cloud-based availability zone? So zone 1 belongs to pool 1 and zone 2 belongs to pool 2, etc.
Oh yeah, that's a good question. So yeah, so actually we can leverage the pool concept to achieve the fault domain isolation. So basically, the pool is configured by some property within the instance config. So in order to be availability zone awareness, so what you need to do is when you start the cluster, you can fetch the availability zone info from the cloud environment and then set that as the pool ID for a server. Then servers from the same zone will be configured as a pool. And then basically what it achieves is if the whole zone down, that means one pool is down, but all the tables on this cluster are still available. Does this answer the question? Okay,
Yeah,
there's some delay. So
yeah,
if it doesn't answer your question, feel free to reach me on the Slack, and then I'll give you some detailed documentation on this.
Thanks, Jackie. We do love good questions, though. When they come in, when people ask good questions, it makes you think, you know? So, yeah, Logic Matt said, thanks, Jackie. Okay, cool. So if there's no other questions for right now, like I said, I will also post the Slack URL just in case you're not in the Pinot Slack. But you can always ask afterwards because there's probably people going to be watching the recording or people who joined late who really don't see it. So, all right, cool. Thanks, Jackie.
Thanks, Corinne. Bye.
So next, I am going to bring in Mayank for the Theta-Sketches in Apache Pinot. Just a little bit of background on Mayank. He is a founding engineer at StarTree, working on Apache Pinot. Prior to joining StarTree, he was a tech lead in the data analytics infrastructure team at LinkedIn and an early member of the team, and then started Apache Pinot, an early member of the team that started Apache Pinot. His contributions at LinkedIn helped Pinot scale from serving dashboards to high throughput, low latency use cases, such as LinkedIn's member feed. Prior to LinkedIn, Mayank spent a good part of his career solving NP hard problems in the EDA industry. Welcome, Mayank.
Thank you, Corinne, for the intro. Thank you so much. I guess it was a mouthful.
No, it's a really good intro. You know, I think that sometimes it helps to have some background on who the presenters are, so like people understand. I feel like I learned a little bit about you when I was reading it. I was like, oh, that's interesting. I didn't know that. So yeah, I'll let you take it away, and then we could do a Q&A afterwards. But like I said already, for any of the attendees, if you have questions, feel free to ask. We can either save them for the end. If they are like, if you put like Mayank at the top, at the front of it, we'll know to save it for Mayank. But there might be other people trying to help answer their questions too, but we can still address them. So thanks for joining. I'm glad I was able to keep you backstage during me telling the bio, because that's always an awkward moment. I did that with Jackie. He's just sitting there. It's like when people sing you happy birthday and you just have to sit there and you're like, I don't know what I'm supposed to do. All right, Mayank.
I don't do well in those situations.
I don't think anybody does. No one knows what to do. All right, so I'll jump off and I'll see you guys after the presentation.
All right. Hello, everyone. I will be talking about the count string problem in general and some of the techniques we use in Apache Pinot, specifically Theta-Sketches to solve that problem. So a quick rundown of the talk here. Let's first discuss what the count listing problem is, how common it is, maybe then discuss some of the approaches, their pros and cons, and then zoom in a little bit on the Theta-Sketches approach for solving the problem, and then we'll have some Q&A. So with that, let me start. So the count listing problem is a fairly simple one, but it's also a very common one. It's present everywhere. So examples, let's say I am a website owner. I want to track how many users, monthly or daily unique users that are visiting my website, right? That's a good thing to know. If I'm an advertiser, I want to know how many unique people my ad campaign is reaching. If I'm an app developer and I deploy my latest release, I want to gather statistics on it. Are there any bugs and issues, and how many unique of those are happening around the different deployments? If I'm in security, I want to prevent a DDoS attack. I want to check if there are, and how many unique IP addresses are hitting my services, and infer something around it. So as you can see, it's everywhere. These are just simple examples. But it is the problem itself is really compute intensive if you want to do it in an accurate way. So for the next few slides, let's actually have our discussion anchored around this simple member schema table. Let's assume we have a table which is capturing when a member worked at a particular company, what title, and when they joined. So for example, we will have, the first row here represents member ID 123, who worked at Amazon as an engineer from December 2015 to March 2020. So a really simple schema from that perspective. Now, let's say we want to start asking some questions, and let's figure out how we answer those questions. So the first question we want to ask is how many new members joined LinkedIn in the year 2020, right? So it seems pretty simple, pretty straightforward. First, I mean, if you just think about it logically, what you want to do is figure out all the members, all the rows where a company equals LinkedIn and start date is somewhere in 2020 and take a count of those. So it's a really simple query. It looks like this. So you're doing a select count star from the table where company is LinkedIn and start date is between January 2020 and December 2020. So far, so good. Really simple. Nothing interesting happening here. So before we proceed further, a quick recap in case you have seen this, but if you have not seen this, I think this will be useful to just understand how query execution works in Pinot. So Pinot essentially has three components. There is the Pinot controller, which is the brain of the distributed system, and it's also responsible for storing some metadata. In this particular case, essentially what it stores is the segments or the shards assignment on server. So which shard is present on what server, that kind of information. The server themselves are responsible for hosting the shard and also executing the query on the shard that they host. And the broker component is the guy who receives the query from the client and is responsible for orchestrating the entire query and returning the result back. So in our example, we were just doing, count star where company equals LinkedIn and start date is between the interesting time. So let's say that query comes in, the broker parses the query, figures out it needs to fan out the query to these two servers, and the server receives those queries. Now, what happens here is individually the servers, they are hosting some part of the data. So for that data, they will select the rows that satisfy the predicate and then just count the number of rows. And both of these will return a single count value, right? So for example, if if the offline server saw like 4 rows that match that criteria, it will return 4. The other guy, let's say, returns 5. Broker receives those, and the broker returns 9, and you're good, right? So just a simple count star query. Now, let's make it a little bit more interesting in terms of the question and also tweak the data that we're playing with. So if we wanted to now answer the question, how many members joined LinkedIn during the years 2019 to 2020? And also, we slightly tweak the data so that there is 2 rows for a member. And the reason why there is 2 rows is because the member got promoted, right? So he has 2 start dates now, one for the original position and the other one for the position when he got promoted. So does the count starter query work here? As you can imagine, it does not, because you will select 2 rows and the answer will be incorrect. Essentially, you want to select one of those. So this is where count distinct works. Pinot already supports it. This is the query. You have the same query, except that you have replaced the count star with distinct count on member ID, and you're good. So let's understand a little bit. So we did talk about how the count star query works. Let's see if the distributed count distinct also works the same way. So you may have already figured this out, but just for the record, let's walk through this. One of the issues that you cannot do a divide and conquer or a scatter gather for count distinct is as follows. If you see in the previous slide, there were 2 rows, right? What happens if you are in a situation where one of the rows is in one of the servers and the other row is in the other server? When the servers are executing the query, they are seeing unique value of 1, individually both of them. So they return 1 each to the broker, and the broker now incorrectly gets a result of 2, which essentially boils down to the fact that count distinct cannot be done in a divide and conquer way, the way count star was done. And essentially, a more fancy way of saying this is count distinct is not an additive function, because you cannot take 2 count distinct results and then just add them to get a final count distinct value. So that's one problem, and that leads to the other bigger problem that now, even though you may have had several servers, all they are doing is just evaluating the predicate and returning the raw rows back to the broker. So you have not really used the server's resources as you would in other queries. However, now you've made the broker the bottleneck, in the sense that it has to hold all those raw data from all the servers to be able to get a global view, and then perform a count distinct on top of that. So that essentially means it's CPU intensive on the broker side. The broker has to use a lot of memory for that computation. And you also use a lot of network bandwidth when the servers are passing the data back to the broker. So essentially, yeah. So in essence, it's, if you wanted to do it in a very accurate way, this is a hard problem, or a problem which needs a lot of resources. So this is where approximation algorithms come in. So essentially, if you look at some of those count distinct problems that we had in the first slide, the use cases are not that, I'm really interested in knowing there were 9,766 unique members, right? If you tell me, oh, there was somewhere around 9,000 members, I'm good, right? My purpose is still served. I do not need the full accurate. And this is where the approximation algorithms come in. What these are essentially probabilistic algorithms, which allow you to estimate multi-set cardinality. And also what they do is so in order to do the accurate count distinct, you had to have the global view of the entire data in memory. So your memory requirement is actually linear on the data size. Whereas in these algorithms, they provide a probabilistic model, which is a lot more compact in terms of storage. And it does so on the, by sacrificing a little bit on the accuracy side. So that's already a win. The other big feature that most of these algorithms provide is that property that they are additive. What that means is that now these can actually be computed on the server side, and the servers don't have to return back the raw result. So all the problems that we discussed in the previous slide are actually mitigated here, so long as we are okay to live with the accuracy trade-off, right? Typically, these algorithms, the operations that they provide are, they have a data structure wherein you can actually keep on adding elements. and then ask questions like, at this point, what is the unique count or the count distinct or cardinality of the set? Given two sets, merge the two, and then get the count distinct. Or there are certain algorithms which will also allow you to do a lot of set operations, like intersection, set difference, and so on. So one such algorithm is the hyperlog-log algorithm. Without going into the mathematical details of it, essentially what it is doing is it's building a probabilistic model using the observation that if you have a stream of integers coming in, if you just monitor their number of leading zeros, the number of leading zeros, suppose it is n, then 2 to the power n is a very good estimation of the cardinality. Of course, this is just a very, very overly simplified statement here, but in case you guys are interested, you can read a lot more about. There's a lot of material out there on hyperlog logs. What this data structure also does is provides you a really compact, the name hyperlog log actually is coming from the fact that it is using sublogarithmic storage, but still providing a high level of accuracy. And obviously, as I mentioned, these algorithms are always additive. So that's also a big win. So let's see, let's go back to our example here, right? We had a member who got promoted and hence he had 2 rows, and we wanted to figure out the count distinct value and to answer this question. And the way to do it is simply change your distinct count function in the Pinot SQL to count distinct HLL, and you're done, right? That's as simple as that. All right, let's make the question a little bit more interesting. So now we want to answer the question that how many members worked at LinkedIn but not at Google. And we also modified the data such that you have some members who actually worked at LinkedIn as well as they were at Google at some point in time as well. Now, if you wanted to answer the query with the same structure as before, like you have a where clause where you're choosing the rows and then simply performing an aggregation on the rows that are chosen, you can no longer do that. What you need is essentially a lot more complex query. Essentially, it would look like a nested query where the inner query will first filter out all the members who don't work at Google, and then use that, the outer query will use that as an input to further select all the members that work at LinkedIn and then perform a count distinct on top of that. So as you can imagine, these the queries become nested, they become complex, and a lot of problems comes with that if you are looking for really fast answers. So this is where Theta-Sketches come in. Like hyperlog-log, these are also probabilistic algorithms. But in the case of hyperlog-log, it was a different heuristic. Here, it's more of a generalization of the kth minimum value problem. Again, I'll spare the mathematical details. There's a lot of material out there for that already. One key difference here in Theta-Sketches is that it allows you to do union, intersection, and set difference, which hyperlog-log did not. And let's see how we can use this to solve the problem that we had. But before that, let's just do a quick comparison between the two. So hyperlog-log essentially is, in terms of storage, is sublogarithmic, whereas Theta-Sketches use a lot more memory in comparison. The actual count distinct function operation is just constant time, but you have to keep in mind that you're also doing other things like merging and set intersection, which may not be constant time. In terms of accuracy, hyperlog-log has seen to be done a lot more accurate for the given size, whereas Theta-Sketch it's not just the size of the sketch, but also things like the type of the data and the query. And I'll cover that as an example in one of the later slides on how that happens. Hyperlog-log only provides unions, whereas Theta-Sketches provide union, intersection, and set difference as well, which comes in handy for a lot of other use cases. So with that, let's first understand how Theta-Sketches look like in Pinot in terms of the using of the aggregation function itself. So the name of the function, aggregation function, is called distinct count Theta-Sketch. It has the following parameters or arguments. The first one is the aggregation column name, the one that you want to do a count distinct on. For computing Theta-Sketches, we use the data sketch library from Apache Data-Sketches, and that library itself has some parameters that are configurable. For example, there is a parameter called nominal factor, which is essentially a measure of how much, what the size of the sketch is, which essentially translates into the accuracy. So we allow the queries to pass these parameters directly to the sketch, so that users can actually trade off accuracy versus cost of storage in memory storage and so on. But it is an optional parameter in the sense that you can actually pass a null string, empty string here, and some default value will be used. Then is an interesting one is this parameter is a list of predicates for which the servers need to compute the sketches on. And this will become more clear when we work on an example for that. Again, this is optional in the sense that in the end, what you want to do is evaluate a set expression. So either you have the set expression, which is instantiating the predicates themselves, or you can have the list of sketches defined here in one of these arguments, and then use the $sign notation to do something like set intersect $1, $2, where $1 and $2 are the predicates that were defined in the optional arguments in the order of their appearance. So to answer our question, we wanted to answer how many people worked at LinkedIn but not Google, right? So this is how the query would look like. Distinct count Theta-Sketch on member ID. We are using 1024 as the size of K because we saw that the accuracy was good enough for this case. And so what essentially happens is these predicates, they actually go to the server. So when the server receives this query, it will first select all the rows in the where clause, which is all the rows where company is in LinkedIn or Google, and then they will create 2 sketches, one of each of the predicate listed in this section, and then they return these sketches back to the broker. Once the broker receives those sketches, it does 2 things. One is it will aggregate all the sketches from different servers for each one of those predicates. Like server 1, 2, and 3 actually may have returned 1 sketch each for this. So you have to do merge the sketches which belong to company equals LinkedIn, and then separately the ones that belong to company equals Google. And once you have that, the broker does a set difference on the 2. And then does the cardinality estimation on that and just returns the value. So this is how the function will look like. So this was a very simple example, but Theta-Sketches are a lot more powerful algorithm, and there is essentially a lot of cool things that you can enable using these. One of the common ones that Theta-Sketches is used for is what's called funnel analysis. It's a powerful analysis technique that finds its usage in a lot of domains, from marketing, sales to e-commerce, and so on. So let's just spend like a little bit of time understanding what it is and how it is valuable. So let's assume you are the owner of a website where you're selling some products, right? So typically, the members or users of your product actually will go through different stages. There's people who will visit your website. Let's say a lot of people visit your website, but not all of them actually continue and shop on the website. And from the ones who shop on the website, not all of them actually go to an actual product. And from those ones, maybe there's further reduction on people who actually check out and place an order and so on. So it starts looking like a funnel because at each stage you're losing people in this particular case. And what you want to figure out is things like on what stage did I lose a lot of people, and is there anything that I can do about it? So as you can imagine, fixing the problem where you see a lot of drop requires finding the problem first, and this is a really good way to do that. So let's see how we would solve this using Theta-Sketches. Oversimplifying the problem here, let's just say there is a simple schema like user ID to identify the user. Pages is essentially each one of the pages listed on the right-hand side. The action that the user took, maybe they just viewed, maybe they clicked on certain things, and at the time which they did that. So now the question that we want to answer is how many people who visited the website for the first time actually ended up clicking on a product, right? And this seems like an interesting question to answer. So the way you would do it is you would, essentially model each one of the blue bars on the right as a sketch, and then you can just all you have to do is set operations on those to be able to answer those questions. One interesting thing to note is that not every user may follow this funnel track. Some of them may directly view a product because they got a link from a friend or something. And you want to be able to also take into account those and set differences where those things might actually be able to compute. The actual query will look like this, wherein again, we have the Theta-Sketch function. We're doing a count distinct on the user ID. We picked a nominal factor of our liking, and now we have, instead of the simple predicates, now we have a little bit more complex predicates. So going from the where clause will select all the rows where page is the landing page and action is viewed, or page's product page and action is clicked. So you got like the superset of things, rows that you are interested in, or the set of the rows that you are ultimately interested in. And the servers will again create two sketches, one for each of the predicates listed in the predicate list argument, and return back to the broker side. And all the broker has to do is now intersect these two, and there you go, you have the answer for the query. So as you can see, like there's, we've talked about the basic use case, we've talked about an interesting use case, but let's also study a little bit on Theta-Sketches on like what are the pros and cons and so on. So I had briefly mentioned that hyperlog logs are really good if you want a lot of accuracy, in a very compact storage, but you don't necessarily need, to support set operations. All you need is just set union and you're good. Then hyperlog log works fine. Theta-Sketches comes in picture when you need a lot of more complex operations like set intersection, set difference, and so. I had alluded to what was the Theta-Sketch parameters. So there's something called the K nominal entries, which is nothing but you can think of it as the size of the sketch itself, which is used for modeling the set. And on the right-hand side, if you see, there's essentially, as you go down the table, you're increasing the size of the sketch. And if you go from left to right, you are seeing that from top to down, the error actually reduces as the size of the sketch increases. And from left to right, your confidence level at different intervals increases, or actually reduces as you go from left to right. So in our case, we had a value of 1024 for K. So we are, 95% confident that there is going to be that our error margin is about 6% or so, and then 99% confident that it's less than 10%. So that's essentially how you kind of measure how accuracy and the size of the sketch differ. One of the things that is actually known already, but we also did notice in our application when we were trying to solve a problem using Theta-Sketches is that, and this is again one of the things that I had mentioned in the earlier slides, that the error is not just a function of the sketch size, but it's also a function of the query and the data properties, right? So essentially what you see is that if you have two sets which are of similar cardinality, and you're performing an intersection on those, the accuracy is high. But if the sets are very disproportionate in size compared to each other, the more the disproportion, the more the error. I mean, to think about it intuitively, let's say on the right-hand side, the set A has a cardinality of 1 billion. But clearly, not all the 1 billion items are stored here. We are just storing some sample representation. And then set B just had one entry, and so we ended up storing that one entry. When you do intersection of those two, since A is already sample, the probability that you have the item that's in B becomes lower and lower, to the point that it actually, you're all guaranteed a wrong answer, right? And so that's kind of a way to intuitively think about why this happens. One of the techniques to solve this problem is, if you do know that there are certain columns or dimensions that generally tend to be larger in terms of set cardinality, what you can do is you can actually break them down into different charts or different subset, and then use this property of this from set theory to break down the set A, which let's say is the one with the higher cardinality or higher size, into smaller sets like A1, A2, A3, and so on. And then the overall intersection of A with B actually can be computed as union of intersections of those subcomponents of A with B. So this is one of the ways that we actually did end up using in terms of improving the property in one of the use cases that we solved using Theta-Sketches. So just to conclude, we've gone through ConDistinct, it's really, how common it is, why it is expensive to do it accurately, what are the different techniques to solve using approximation, when to use which one, and we also talked about Theta-Sketches. So that's my slide. I'm going to open it up for Q&A.
Hi, thank you, Mayank.
Hello. Sure.
So I did write in the chat that if anybody has any questions, please ask them now. There is a delay in the video, so we're like 15 seconds delayed, so like write them really quickly. Cool. So I'll keep your slide up for a minute. We'll ask a question, and then I'll bring in Jackie also. So if anybody else has other questions, they can ask. So Logic Mac.
I think it's better to ask Jackie to bring him now, because he also worked on Theta-Sketches. So
okay.
Both of us can defend those.
Okay. So Logic Matt asked, is Theta-Sketch applicable to text index? So I want to figure out all cardinality from the text index so that I can further filter my search based on some cardinal values.
That's a good question. I'll have to think about it. I mean, I personally haven't really solved in that way. I need to understand the question in a little bit more detail. Is it all right that we chat offline on the Pinot Slack?
Yeah, or we can also give him. There's another question coming in, so we can also give him a minute to elaborate, or we can also ask him this in the
right
chat also.
But I think that one will require a little bit of back and forth in terms of understanding the use case.
Got it. Okay. All right. And also we have Xiaobing said, is the accuracy improvement via set theory done by Pinot internally?
Not at the moment. No, this was done on the application or the client side for the use case that we worked on. But great question, though. I think it's something that we did talk about with the application team at the time to push this down into Pinot as well, because Pinot does have the information. We just haven't done that yet. But yeah, I mean, we can put it in the backlog and get back to it. Seems like a good thing to do.
Cool. I'm going to remove I'll put your slide deck backstage. We don't need that anymore. If there's any other questions, please ask now. We can give people like 30 seconds or something, so that way we can give them an opportunity to write it out. Because sometimes that happens. We're like, just as you're about to cut it off, a couple questions come in. But thank you guys for doing this.
Absolutely. Well, Jackie has been doing this every week. I've been backstage most of the time, just trying to answer questions. But yeah, thanks, Jackie.
But that's a big deal too, Mayank, because you're always in there, and
Thank you.
You're very active about like, how can I help? How can I be involved? And I think it's pretty awesome.
Well, it's all about the community, right? I mean, we want, I think everybody in the Apache Pinot community wants to help and see the product, successful. Some of us, including myself, Jackie, and a whole lot of us who actually, started it. So we're very passionate about it. Really want to see it succeed in the community. That's all we're trying to do.
Yeah. It's awesome. Well, Jackie did put like in his bio that his goal is to make
Yes.
Apache Pinot the fastest online analytics platform in the market, which I think is really
Yeah.
funny. Like who puts that in their bio? Like Jackie puts it in his bio.
Yeah.
Rohit said, great session. Mayank, Pankaj said, great session, Jackie and Mayank. Thank you guys for the feedback, by the way. It means a lot to get feedback on like the presentations or like the code or the projects, the integrations, like anything that's being built, like to give, you know, a lot of the contributors, the feedback is really helpful. So Logic Matt is elaborating a little bit. It's something that I feel like if I read it, it's just going to sound ridiculous.
Yeah, unfortunately, I don't have the YouTube window here.
Okay, so it says, for example, if my text is XXYY, XXZZ, YYCC, then I would like to fetch the cardinality as XX2, YY2, ZZ2, which helps me to filter the search with values, say, XX.
Yeah, I'll have to think about it. I don't think we support that. I think this is essentially doing Theta-Sketches within a row. And Jackie, feel free to jump in if you feel otherwise. So that isn't something that we do yet, but yeah, and that's something we can definitely elaborate, explore.
Yeah, I'm thinking how to model this. So it's not supported with this data model, but maybe we can model the data some way to support it. I still didn't fully understand the problem.
Yeah, I know. I think we need Logic Math, please. Yeah. Let's connect on Slack. I think it will be easier for us to understand, and But I think at the face of it, I don't think we support it right now. But I think we would like to understand the use case and maybe like what Jackie's saying, help modify the data model a little bit so it makes it easier.
I'm pretty sure I've seen Logic Math either like the meetups or the Slack before, so I'm pretty sure that is in there. But okay, so Xiaobing asked, is it needed to put sketch predicates in SQL where clause, or put it another way, are those sketch predicates actually pushed down during query execution? And then Kishore said, if Theta-Sketches takes UDF expressions as input, this can be supported.
Yeah, I think Kishore answered it.
Cool. Okay.
I think Kishore is answering the question from Logic Math.
Okay.
Oh, so yeah, he's not answering the sketch predicates in SQL where clause.
So if I understand the question correctly from Xiaobing, what he's saying is maybe the predicates look similar in the where clause versus what's being passed in the argument. And if that's the question, it's a great question. There's a very subtle difference there. The difference is that in the where clause, you are actually doing an or, in the sense that you are selecting as many rows as possible for the servers to select those different sketches. In the example that we discussed, you're doing an or of LinkedIn or Google, where company in LinkedIn or Google, right? And then when it goes to the broker side is where the intersection happens. If you did an and on the where clause, then you will not get any rows. Every row will be there will not be a single row that satisfies that condition. If I understand the question correctly.
Cool. If you didn't understand it correctly, you can give it a minute to elaborate.
Well, Slack.
Or Slack.
Slack.
I did include the URL to the Apache Pinot Slack, and we'll also put it in the description of the YouTube once this video gets published. So, yeah. Cool. Thank you guys so much for taking the time and putting this together and working on it and putting together the presentation and taking the time to do the presentation. It's really awesome.
Thank you. You all have been helping us, take these series of events throughout. Awesome job.
That's awesome. All right, so we will see you all tomorrow. There's another meetup, Pinot and Debezium. I think it's tomorrow. right? And then we have another one on Thursday for operating Apache Pinot at Pinot scale, at operating Apache Pinot at Uber scale. Pinot scale is also a thing, so that's good too. All right. Logic Matt said, thanks guys, appreciating having detailed sessions like this. That's awesome. And that feedback is also good for us because then we know to bring more of it. So if anybody who's watching and you have any thoughts or things that you'd like to see more of, please let me know. I'm also on the Pinot Slack. Just anything that you think about that, like, I would really like to dig into this a little bit more, let me know, because that's how we're going to basically direct our content, is by what people actually want to hear. All right. All right, cool. Well, thank you guys all so much for watching, and everybody for attending, and you guys for presenting. And don't forget to like, comment, subscribe, give us a star on GitHub if you love the Pinot project. And hopefully we'll see you guys tomorrow. Bye.
Bye.